Introduction to TCP/IP. TCP/IP is the foundation of modern networking and the Internet. It provides the rules and standards that enable computers and devices to communicate across networks. The suite includes protocols for data transmission, addressing and routing, file transfer, email, network management, and diagnostics. Understanding these protocols is essential for any IT professional, especially for CASNBDNSA candidates. This lesson covers the most important TCP/IP protocols, their functions, port numbers, and practical applications. Each protocol serves a specific purpose in network communication, from transferring files to sending emails and managing network devices. Transmission Control Protocol. TCP is a connection-oriented protocol that provides reliable, ordered, and error-checked delivery of data between applications. TCP establishes a connection before data transmission begins using a three-way handshake. The client sends a SYN packet, the server responds with SYN ACK, and the client sends ACK to complete the connection. TCP provides reliable delivery through sequencing and acknowledgement. Each packet is numbered, and the receiver sends acknowledgements for received packets. If an acknowledgement is not received, the sender retransmits the packet. TCP features and ports. TCP ensures data arrives in the correct order and includes flow control mechanisms to prevent overwhelming the receiver. TCP performs error checking using checksums. If a packet is corrupted during transmission, it is discarded and retransmitted. TCP uses port numbers to identify specific applications and services. Well-known ports range from 0 to 1023 and are assigned to common services. TCP is used for web browsing, email, file transfers, remote access, and database connections. Common TCP ports include HTTP on port 80, HTTPS on port 443, SSH on port 22, SMTP on port 25, and FTP on port 21. User Datagram Protocol. UDP is a connectionless protocol that provides fast, lightweight data transmission without guarantees. UDP does not establish a connection before sending data. There is no handshake. UDP provides unreliable delivery where datagrams may be lost, duplicated, or arrive out of order. There is no acknowledgement or retransmission. UDP is lightweight with low overhead. The UDP header is only 8 bytes compared to TCP's 20 bytes. This makes UDP faster and more efficient for certain applications. UDP has no flow control or congestion control mechanisms. UDP is used for streaming media, VoIP, online gaming, DNS queries, DHCP, and SNMP. UDP ports and TCP vs UDP. Common UDP ports include DNS on port 53, DHCP server on port 67, DHCP client on port 68, and SNMP on port 161. TCP is connection-oriented while UDP is connectionless. TCP provides reliable delivery while UDP provides best effort only. TCP preserves order while UDP has no ordering. TCP has higher overhead with a 20-byte header while UDP has low overhead with an 8-byte header. TCP is slower while UDP is faster. TCP has flow control while UDP does not. TCP is used for web browsing, email, and file transfers while UDP is used for streaming, VoIP, and DNS. Dynamic Host Configuration Protocol. DHCP automates the assignment of IP addresses and other network configuration parameters to devices on a network. It eliminates the need for manual IP configuration. DHCP operates on a client-server model. DHCP servers maintain a pool of IP addresses and lease them to clients. DHCP clients request and receive IP addresses from the server. DHCP provides automatic IP address assignment, subnet mask, default gateway, DNS servers, and other configuration parameters. DHCP leases IP addresses for a specific duration. When the lease expires, the client must renew it or obtain a new address. DHCP supports address reservation where specific IP addresses are permanently assigned to specific devices based on their MAC addresses. DHCP process and DNS. The DHCP process follows 4 steps known as DORA. Discover: the client broadcasts a discover message to locate a DHCP server. Offer: the DHCP server responds with a offer message containing an IP address. Request: the client broadcasts a request message accepting the offer. Acknowledge: the DHCP server sends a back message confirming the lease. DNS is a hierarchical and decentralized naming system that translates human-readable domain names to IP addresses. DNS operates on a client-server model. DNS clients called resolvers query DNS servers to resolve domain names to IP addresses. DNS servers maintain the hierarchical namespace and respond to queries. DNS records and function. DNS uses both TCP and UDP. UDP is used for simple queries and responses while TCP is used for zone transfers and large responses exceeding 512 bytes. DNS follows a hierarchical namespace. The root zone is at the top followed by top-level domains like .com, .org, and .net. DNS record types include A records that map a host name to an IPv4 address. AAA records map a host name to an IPv6 address. Name records create an alias for a host name. MX records specify mail exchange servers for a domain. NS records identify authoritative name servers. PTR records map an IP address to a host name for reverse lookup. Network address translation. NAT is a method of remapping one IP address space into another by modifying network address information in IP packet headers while they are in transit. NAT conserves public IP addresses by allowing multiple private IP addresses to use a single public IP address. This is essential given the limited availability of IPv4 addresses. NAT enhances security by hiding internal IP addresses from external networks. Internal devices are not directly reachable from the Internet. NAT modifies the IP header of packets, changing source and destination addresses as they pass through the NAT device. NAT maintains a translation table to track connections. NAT types include static NAT, which maps a single private IP to a single public IP. Dynamic NAT maps private IPs to a pool of public IPs. PAT maps multiple private IPs to a single public IP using different ports. Secure Shell and HTTP. SSH is a cryptographic network protocol used for secure remote login, command execution, and other secure network services. SSH provides encrypted communication between client and server. All data transmitted is encrypted to prevent eavesdropping and tampering. SSH supports multiple authentication methods including passwords and public key cryptography. SSH uses TCP port 22. SSH is used for secure remote administration of servers and network devices. HTTP is an application layer protocol used for transmitting hypertext documents such as web pages. HTTP is a stateless protocol. Each request-response pair is independent. HTTP uses a client-server model. The web browser acts as the client sending requests to the web server. HTTP uses TCP port 80. HTTP status codes indicate the result of a request. HTTPS and FTP. HTTPS is the secure version of HTTP that uses encryption to protect communications between client and server. It combines HTTP with TLS and SSL encryption. HTTPS encrypts all data transmitted between client and server. This prevents eavesdropping and man-in-the-middle attacks. HTTPS uses TCP port 443. HTTPS provides server authentication through digital certificates. HTTPS is used for secure web browsing, online banking, and confidential data transmission. FTP is a standard network protocol used for transferring files between a client and a server. FTP uses two separate connections. A control connection on port 21 for commands. A data connection for the actual file transfer. FTP supports active and passive modes. FTP is not encrypted by default. Credentials and data are transmitted in plain text. Email protocols. SMTP, POP3, and IMAP handle email communication. SMTP, which is Simple Mail Transfer Protocol, is used for sending and relaying email messages between servers and from clients to servers. SMTP uses TCP port 25. SMTP supports authentication to prevent unauthorized use of mail servers. POP3, which is Post Office Protocol version 3, is used for retrieving email from a mail server. POP3 downloads messages to a local email client and typically removes them from the server. POP3 uses TCP port 110. IMAP, which is Internet Message Access Protocol, is used for retrieving email from a mail server while keeping messages stored on the server. IMAP allows multiple clients to access the same mailbox. IMAP keeps messages on the server by default. IMAP supports multiple folders and server-side searching. IMAP uses TCP port 143. Simple Network Management Protocol. SNMP is an application layer protocol used for managing and monitoring network devices such as routers, switches, servers, printers, and other IP-enabled devices. SNMP uses a manager-agent model. SNMP managers monitor and control SNMP agents running on network devices. SNMP uses UDP port 161 for manager-agent communication and port 162 for trap notifications. SNMP has multiple versions. SNMP version 1 is the original version with minimal security. SNMP version 2C improves performance but still lacks strong security. SNMP version 3 provides encryption and authentication. SNMP operations include get to retrieve a single value, get next to retrieve the next value, get bulk to retrieve multiple values, set to modify a value, and trap for asynchronous notifications. Internet Control Message Protocol. ICMP is a network layer protocol used for error reporting and diagnostic functions in IP networks. ICMP is primarily used for error messages. When a router cannot deliver a packet, it sends an ICMP error message back to the source. ICMP supports diagnostic tools including ping and traceroute. ICMP is not used for user data transmission. Common ICMP message types include echo reply, which is the response to an echo request, or ping reply. Destination unreachable for network, host, protocol, or port unreachable. Redirect to redirect datagrams to a better gateway. Echo request for ping requests to test connectivity. Time exceeded for TTL expired during transit or traceroute. ICMP is used for network connectivity testing, route discovery, and network diagnostics. Address Resolution Protocol and Summary. ARP is a network layer protocol used to map IP addresses to MAC addresses on a local network. ARP operates within a single network segment. ARP uses broadcast messages. An ARP request is broadcast to all devices on the local network. The device with the matching IP address responds with its MAC address. ARP maintains a cache of resolved addresses. The ARP cache stores IP to MAC mappings to avoid repeated broadcasts. ARP entries in the cache have a time to live. ARP is used by all devices on a local network for IP to MAC address resolution. Quick reference summary. TCP provides reliable data delivery. UDP provides fast data delivery. DHCP assigns IP addresses automatically. DNS resolves names to IP addresses. NAT translates IP addresses. SSH provides secure remote access. HTTP enables web browsing. HTTPS provides secure web browsing. FTP transfers files. SMTP sends email. POP3 retrieves email and deletes from server. IMAP retrieves email and keeps on server. SNMP manages network devices. ICMP provides network diagnostics. ARP resolves IP addresses to MAC addresses. This concludes the TCP/IP protocols lesson.